So far? No? All clear? Started? Consensus, then hard fork, a rule change that alters block validation. Suppose when you try to solve that complex equation, suppose two groups or two nodes, they find out the answer exactly, so then you can change that rule. Occurs when two miners find a block simultaneously, leading a network split. So you can change the rule how you want to add that block into the blockchain. When two nodes, they identify that hash simultaneously, then you cannot give the reward to any one member. Okay, then you can change the rule of adding the block into the blockchain. Again, Merkle tree. What is this Merkle tree? Also known as a hash tree. Okay, so here each leaf node, hash tree, it includes the different hashes. Each leaf node contains the hash of a block. Okay? And with while non-leaf nodes store the hash of their child nodes. Okay, so that is called your Merkle tree, where you get the information of all the hash of that blocks. Node. What is node? Computers in the blockchain network are called nodes. Suppose there are five nodes are there, means each node is for one entity. Supplier, there is a one computer. For manufacturing, there is one computer. Then distributor, retailer. So how many computers are available, or how many stakeholders are involved in that network, that is called node. Computers in the blockchain network are called nodes. Each node maintains a copy of the ledger. Each node means each computer keeps the copy of that the ledger, whatever the transaction you are doing. Nodes validate transaction and ensures integrity. As I said, nodes means you are saying that majority of the people, they approve the transaction, means nodes means computers, they approve the transaction and then they ensure the integrity. Transaction. What is transaction? Simple. Smallest unit in blockchain containing records, data and information. So in your block, transaction means smallest unit, who is the supplier, who is the receiver, how much products you are sending, what you are sending, what is the quality of that products. It contains the records, data and information of that transaction. Includes sender and receiver details along with the transaction value. Suppose Venkat is sending some money, who is the sender, who is the receiver, how much he is trying to send, all that information. Uses digital signature for security and timestamp. So you need to approve it. You cannot just verbally call and say that I approve it. So you need the digital signature. So it uses the digital signatures for security, and again it is timestamp, so that you can see when that transaction is approved. Addresses. So unique identifiers for senders and recipients. So when you do the transactions in this cryptocurrency, so there is an address each for senders and the receivers. A public key serves as the blockchain address. So there are two kinds of key. Public key, which is available to see to everybody involved in that network, and the private key as well. Private key, that is only for you. Once you lose that private key, what will happen? You cannot claim your blockchain asset, whatever. So that uh, private key is basically your blockchain wallet. Okay, so whatever the cryptocurrency blockchain, whatever the coins you are keeping into that one. Once you lose that private key, you cannot claim that blockchain asset. Public key is available for everybody. What is the use of public key? With the help of public key, they can approve the transaction. Block. Block means it contains transaction details such as timestamp when this transaction happened, previous block link. So the hash of the previous block, you need to use it for creating a new block. It uses a secure hash algorithm to ensure the integrity. So each block, they use this hash algorithm to create that integrity in the blockchain. consists of two parts. So each block, it includes two parts, block header and block body. So what is that block header? So block header, basically you see the information, block body, then you have the main components that blockchain. Chain block, you know, it includes the transaction, your timestamp, previous block. Chain means when you connect the blocks, sequential arrangement of blocks creating a link structure. So you create those block interlinking with the previous block, so that's called your block and the chain. When you connect those blocks, it becomes the blockchain. I will show you some examples of the how it that each block looks. Cryptography definition: cryptography protects information by encrypting and decrypting data, ensuring security and trust in blockchain networks. I hope you know what is encryption and decryption, and they use this encrypting and decrypting the data to maintain the security of your blockchain networks. What are the key roles of this cryptography in the blockchain? Hashing, used to link blocks and maintain consensus. So you see this hashing algorithm. What is this hash? So basically it is used to link the two blocks, and then it as also it maintain the consensus in your blockchain. Asymmetric key cryptography identifies users and proves ownership. So this is, as I said, your public key, private key. With the help of private key, you can identify who is the owner of that blockchain, that asset, and proves the ownership as well. Trustless environment, it eliminates the third party intermediaries. Because of this cryptography, you don't need the any third party to approve that transaction, to make sure that this transaction is safe, and it is it is not any tampering has been done there. Hashing in blockchain, hashing converts data into a fixed length unique hash value using cryptographic algorithms. So there are some cryptographic algorithms you can see here, SHA-256, and we use these algorithms to convert the data. So suppose in one block, when Venkat sends the money, who is the receiver, who is the the sender, and how much money they are transferring. So this information is there. So you need to convert this information into the hash. You need to convert this. You cannot simply write there, okay, sender is Venkat, receiver is Chinmay, and he is transferring 100. Is it safe? Everybody sees who is the sender, who is the basically the receiver. So here hashing converts that data, available data stored into that block, into a fixed length unique hash using cryptographic algorithms. What are the features of this hashing? Unique identification of data for each data. Suppose he is saying that 100 rupees is transferred, or 100 pounds is transferred from Venkat to Chinmay. So that 100 amount, it will create the unique value in that hash. If you change that value, if you make it 150, that hash will change. Okay, so it depends on, that's why I am saying that why you cannot change the value once the transaction is done, because whatever that hash you are developing, it is based on the available information in that block. When you change the information, then only hash will change, and it is very very complicated. I hope you haven't if you might have seen the whole the hash of any blockchain technology or Ethereum, some 16 17, so many complicated stuffs are there. So in blockchain, for example, in Bitcoin, if you see 16 times the 00 will come, and then after that transaction details will get started. One-way function, irreversible, secure linking of blocks, Genesis block to latest block. Genesis block is your first block, and that blocks then you connect with the rest of the blocks in your network. Examples of hash function you can see. So our input is blockchain. This is the input you want to, and now you want to convert into the hash. Output 81C 885 blah 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 and so on. So if you make small change in this blockchain word, suppose blocks and chain, if you make that small c as a capital T in blockchain, this is the your sixth letter. Okay, if you make this small c into the capital C, the whole output will be changed. So that's why when you make this when you convert the raw data into this unique hash, you cannot you need to be very secure there. You need to be very confident to make sure that you are using the exact information to convert the that raw data into the hash. This is another example. Data blockchain concepts book chapter. This is your input data. Now you wanted to convert into the hash. This is the hash. Can you remind this? Can you remember this? Is it very difficult? You can see. And now what you want to do? You want to change this book, the first alphabet letter, you want to make it small b, and then see. So even you make that small change, blockchain concept book chapter, your whole hash is changed here. Then do you think that you can go back and you can make the changes in that record? It is very difficult. Why? Because whatever the small change you make in that transaction, once it is approved, the whole block will be whole hash will be changed. So that's why we call it as tamper proof, secure, transparent, and unchangeable. Block structure, you can see the block height here. Okay, header hash from previous block. So your first block is Genesis block, and then you take the hash from this previous block, and then you create the second block. So in this block, what you see, previous header hash, the hash from the previous your block, timestamping when this transaction is happened. So that is the information you want to store here. What is the difficulty? Difficulty level means how complicated that hash is there. Merkle root, the hash tree, okay, and then transaction, and then after that this information will be passed to the next block. And then so you can see this is the whole network. This is your first block, then hash will be transferred to the second block, and the not whole hash will be used to make the second block. Only the part of that first hash will be used to create the second block. Then you have got the third, you have got third block, and then n number of. So what is the block content? You write previous hash. So for example, your previous hash is 0, and then your timestamp when that transaction is happening. You are saying Monday 6th of August 2009, 2 o'clock GMT time. So this is the timestamp when that information, when that transaction is happening. Data, what is the data? So this is a welcome to blockchain, just one example. But in your case, the data is that you are giving 100 rupees to the Chinmay, or that is the data. Hash, this is the hash. What is it based on? Is it based on the data? This welcome to blockchain. You change this input data, the hash will change. And then nonce is, what is this nonce? A random number to solve this difficulty, means mathematical equation. This is the random number 45673 to solve that your mathematical equation. Header, it contains the metadata. So what is that metadata? Hash of the previous block. Hash of the previous block. Why do you need the hash of the previous block? Why do you need the hash of the previous block? To make it continuous, interconnected. Do you use that hash for any purpose in this new block? For accessing public key, yes. So when you solve this mathematical equation, you need the previous hash. Without that, you cannot solve that mathematical equation, and then that's why you need that hash. And again, if the previous hash is not correct, what do you think? What will happen? The whatever the equation you are trying to solve, it will not get approved, or you will struggle to solve that. So that's why if previous hash is not correct, your new block will be affected. Timestamp, again you can see here when that basically the information or the transaction happened. So timestamp you can see here. Nonce, random number for mine. You want to solve that equation here using the previous information, the given information here. So we need the random number to solve that one. So that's a nonce. Merkle tree root digital fingerprint of transaction. So this is a digital fingerprint of transaction, means all the hash you can see in that Merkle tree root. List of transaction records all the included transactions. So here transactions in one block, you can add single transaction or you can add multiple transaction, based on when you do those transactions. Block identification, block hash, unique hash id generated for each block. So what is hash? Unique hash id generated for each block. So this is a unique id, and this is you cannot change this because it depends on the input information, it depends on the previous hash. So this is a unique hash id, and then I have shown you the example as well of this unique hash id on the previous slide. So this is a hash id, you cannot change it. Why? Because it depends on the input information available, and then if input data is changed, then only this will change. Otherwise it will be difficult to update this your unique hash id. Records all included transactions. Block identification, block hash means unique hash id generated for each block. Block height, position of the block within the blockchain. Block height, it shows the what is the position of that block in the blockchain. Suppose you have got the 5 or 10 blocks in that network, so block height, it will tell you that whether what is the exact position of that block in the blockchain. Merkle tree ensures the data integrity by linking transaction in a hierarchical structure. So it basically tells you the hash, all the hash IDs, and it will link the transaction in a hierarchical structure, like which transaction happened first, and after that what is the next transaction. So that linking of the transaction is normally done in the Merkle tree. It provides a secure and efficient verification process. You can verify that transaction there, and you can make it secure as well. Blockchain formation, how does then blockchain we make it, we create? Each block contains a reference the previous blocks has. As I said, if you look at this block 2, this includes the information or the previous hash, and then each block contains a reference to the previous blocks hash. Then you use the mathematical equation considering your random number to solve that one, and when you solve it exactly, if it is correct, then everybody will approve it. And if you solve that mathematical equation and if it is wrong, what? Other parties, stakeholders, they will not approve it. So this is exactly the understanding. So in supply chain perspective, transaction is wrong means you are saying Venkat gave 200 rupees and you are making some changes like 500 or 600. So this is a wrong information. So other members, they will not approve that transaction. So here when you solve that basically the mathematical equations to get that nonce, so if it is correct, then everybody will approve it. If it is wrong, nobody will approve it. Creates a secure and non-changeable immutable chain of blocks. That's your blockchain. Each block contains the information about the transaction, then it includes the hash based on the input data, then you use that block to create the another block when the new information is added. How blockchain works, any idea? 1.5 hour. Will is tree already there outside? Okay, yeah, we'll take the break and we will start this. No, 3 hours. He said. When did he say? Uh, okay. Let's see. We'll do. Mm, blockchain types. Is tree outside already? Okay. Yeah, we'll take the break then. It came? Is it working fine? Okay, so we were talking about the blockchain, how blockchain works. So we initiate the transaction initially. The user initiate this transaction. That includes contracts, cryptocurrency records, or you want to share that records with the other members of supply chain. So we initiate the transaction. Once we initiate the transaction, next is to create the block of whatever the record you have got, whatever the content information available with you, and you want to share this information with blockchain, with the help of blockchain, with the other members in your supply chain. So the transaction request is represented as a block in your network. So you can say that new transaction is requested within a new block, and this block broadcasted to every node in the blockchain. So disseminate block. So once block is created, now you need to broadcast that block to the other all the members involved in the supply chain. For what purpose? So that they can approve that transaction. Okay, approval. So the block is created and shared with the network participants. Who are the participants? All the nodes involved in that supply chain. You share that block, and then those, you can say, the block is broadcasted to every node in the, you can see here 6 nodes are there, so everybody can access that block, what is info available there. This is a non-localization, so we are not keeping that block in a central any servers or central localization. So here we are doing the non-localization basically. Then block validation, participants analyze and validate the block. So once this is done, broadcasting is done, the majority of the nodes approve the validity of the transaction. Now you want block is broadcasted to everybody, they know that what is that transaction, what is involved in that transaction, who is the sender, who is the receiver, what is the quantity they are sending. That is done. Now next thing is the approval. So how do they approve it? With the help of some consensus algorithm, contract. So participants analyze and validate the block. So in proof of working consensus algorithm, if majority of the, suppose here 6 nodes are there, if 4 nodes approve this transaction, new transaction, that block is added into the blockchain. If suppose only 2 members approved it and 4 members rejected it, this new block will not be added into the blockchain. Okay, so the block is, once if it is majority of the people approved it nodes, the block is added to the blockchain, and then a new copy of the ledger is saved in distributed networks. So in all the networks, new copy of this distributed ledger is created. Why? Because you added the new block, so then in the existing chain that new block will be added, and the new copy of this transaction, it will be created, saved in the distributed networks. So when they approve it, how does it work? Smart execution. The verification process and adding new transaction to the ledger can be executed by smart contracts. Smart contracts means basically the rules. How do you wanna approve that transaction? That's your contract. Consensus algorithm validation is done using a consensus mechanism. And there are various kinds of consensus mechanism. Validation for attachment. Members validate the block to add into the network. So once block is verified, it goes into the blockchain network. Block attachment, the validated block is added to the blockchain. So this is the way the blockchain works. So now let me and then immutable and permanent. Once added, the block becomes permanent and non-changeable. So once the block is added into the network, you cannot make any changes in that block. You cannot go back and make any changes here. See the supply chain example, how the blockchain works. Initial transaction means transaction start with the shipment, contract or delivery details. Suppose you are doing the shipment to your distributor, retailers. So that shipment is basically the transaction. That includes the tracking number, shipment details, how many products are there, when you are doing that shipment, who is the receiver, who is the third party logistics provider, who is the fourth party logistics provider. Block creation. Once that after that initial transaction data includes the shipping date, product details is packaged into the block. So block includes all these details: who is the sender, who is the receiver, what is the quantity, what is the amount they are transferring. So shipping date, product details. So you create that block. Block is created. Now next, disseminate means broadcast this block to the all participants involved in your supply chain. The block is shared with the supply chain participants, that is supplier, carriers and retailers. So who is the supplier? Suppliers who which supplying the products, retailers who are taking that products, and carriers, third party logistics providers. They should also aware of what is being transported, and what is the quantity, product details, shipment details and all those things. Block validation, then participants who will approve that one: warehouse, transporter, retailer. So the basically the supplier, the retailer, the transporters, third party logistics provider or fourth party logistics provider, they verify the transaction accuracy. Because if I am a supplier and I am adding the exact information on that block, so my retailer, that retailer is also aware of what I am sharing. Logistics partner, we are also involving the logistics partner. So when all these participants they approve the transaction, then it will get validated. After the for validation, consensus mechanism ensure the agreement on transaction validity. Suppose out of these three, one, suppose majority of the, suppose warehouse and retailer, they approved the transaction, and if transporter didn't approve it, so majority is there, so the block is get added into the basically the your blockchain network. Validation for attachment, the block is validated and approved for the blockchain. Block attachment, the block is added to the blockchain network confirming the transaction, and then once the transaction becomes permanent, providing an unchangeable record. So this is a way your blockchain works in the supply chain and logistics area. So there are two kinds of network architectures. So one is with your centralized system like bank central architecture, and another one is the distributed one. So first is the we are going to see some differences between the your network architectures: client and server systems and peer to peer network. So in blockchain, which one do you use? Peer to peer network. So client server means centralized model where a server manages resources and services. For example, bank, government bodies, they have got this client server system, server, and then you have got the clients which try to access the information with using the server. Peer network, peer to peer, decentralized model where all nodes, peers have equal roles. So all nodes, they see this basically the new blockchain or new block added. So this is a decentralized model where all nodes, they see the transaction and they have equal roles to approve that or reject that transaction. So in clients and server system, client send the request, the server processes and responds. So your banking transaction, clients means one person want to transfer the information, that person initiate the request, then server process that request and respond to it. So that's your client server model. Then you have got peer to peer, no central server. Here we don't have any central server, peers communicate directly via message passing. Okay, so basically supplier, all the members involved in that supply chain, they directly communicate with the other members of that network, and then they manage the transactions locally. So there is no central server involved here. Basically peers communicate directly via message passing. Used in enterprise applications, cloud computing and databases. Used in client server means enterprise application, cloud computing and databases. Then used in file sharing, peer to peer means file sharing, BitTorrent, blockchain and cryptocurrency networks, they use peer to peer. What are the limitations of client server? We already talked about a couple of things. Single point of failure, if the server crashes, the whole system fails. Higher maintenance cost. This is the example of your server, and you have got one server, the 4 computers are connected, 4 nodes are connected. Then peer-to-peer advantages, no single point of failure, more resilient, and we have got the backup additional copies of the records as well. Better scalability and efficiency, we can very easily scale this peer-to-peer network, and it will be efficient as well. This is a network, so you can see 5 computers are there, 5 nodes, they are interlinked with everybody, and then they can directly do the communications, and you don't need any third party or server to approve those transactions. There are some types of blockchains. Yesterday we talked about the IoT types. What are the some types of IoT? Consumer IoT, commercial IoT, industrial IoT. So similarly we have the blockchain types. What are the blockchain types? Public blockchain. Public blockchain, it there are some features of this blockchain: permissionless, open to all participants without restrictions. Suppose government is using the this kind of blockchain to share the information with the other members, with the normal public, but they want to make sure that nobody can change any changes into those records. So permissionless, open to all participants without any restrictions. Features full rights to read, write, and maintain the ledger. So you have got full, all the nodes, they have got full rights to read, write, and maintain the ledger. Trustless and immutable, records are permanent and trustworthy, we cannot make any changes there. Examples: Bitcoin or Ethereum. So these are the example of your public blockchain, where information is available to all the participants who are involved in that network. Everybody has the rights to read, write, and maintain that ledger. If I buy one Bitcoin coin, so I can see that what is my hash code, hash ID, who are involved in that one, everything. So records are permanent and trustworthy. And similarly Ethereum is another coin. Then public blockchain. What is next one? Private blockchain. Permission, access restricted to selected participants. Suppose there are some there is a confidential information involved in your supply chain, and you want to make sure that only the authorized people will see those information or data. Then you can use the private blockchain. Like I just said, you now in the game you will get one private key and you will get one public key. Okay, so private key, basically it is your blockchain wallet, where you keep all the information of your blockchain wallet. So access is restricted to selected participants, not everybody involved. But in public blockchain, everybody has the access. Features: transaction records are encrypted, accessible only to authorized users. Use case: ideal for internal trusted networks with identity management. Examples: Hyperledger Fabric, Corda, or Quorum. So these are the examples of private blockchain, and we use these blockchains where you want to transfer the restricted information to the selected participants. Hybrid blockchain, the combination of your public and private blockchain, merges features of both public and private blockchains. Structure: semi-decentralized, semi-private, suitable for cross-organizational use. Means suppose you want to do the cross-organizational collaborations, you can go with the hybrid blockchain, where you can do the semi-decentralization, you can share some information, you can make some information public. Control user group with public and private benefits. So these are the 3 types of basically the blockchain: public blockchain, private blockchain, and hybrid blockchain. So these are the some of the properties: public, consensus algorithm, permissionless, we don't need any consensus to approve the transaction. Private, we need the permission to approve the transaction, only authorized users are allowed. Consortium, permission only. Efficiency: public low, private high, then consortium again high. Determination of consensus: all miners of the block will be participating. Public means all the miners, all the nodes in that network, they will be participating. Here private, users of one organization will be participating. Why? Because of the private nature of that blockchain, only the selected participants will participate there. Consortium, selected set of nodes only will be participating. Read: public, open to public, anyone can read, write, and maintain the ledger. Here can be public or restricted, can be public or restricted. Immutability, tampering is not possible in public. Private possibility of little bit of tampering because of the involvement of the selected participants, and again consortium possibility of little bit tampering. Generations of blockchain. If you look at the blockchain now, how initially it was started, and now what are the some of the coins available in this blockchain. Examples: first generation, initially the Bitcoin, Litecoin and Ethereum, those kind Bitcoin and Litecoin, they are the your first generation blockchains. Consensus mechanism, proof of work and proof of state. So these are the mechanisms we are going to talk about that. Energy requirements requires more energy. Why? Because you need the more power to solve those complex problems for the consensus algorithm, for consensus. And then here requires less energy as compared to first generation. And then third, Cardona Nano, very low. And fourth is still in the development stage. So provisions for variable consensus mechanism. So here the energy requirements is low. Energy requirements means how many nodes are available in that network, what information you are trying to share, and what is the consensus mechanism. So depending on those factors, the energy requirements is decided. Cost: Bitcoin high cost, Ethereum medium cost, then Cardona is low cost, and again fourth is cost effective. Smart contracts: no control over the transaction, unavailability of smart contracts. Smart contract is one of the feature of your blockchain. So in first generation we cannot do that smart contracts, but in Ethereum now you can do the provisions of smart contracts, dApps. Third, support smart contract with the intrinsic verification mechanism. Scalability challenges: uses lightning here, and then can use sharding for improving scalability. Speed: Bitcoin, it is a time consuming because again the huge amount of data, more energy. Ethereum is also time consuming. Cardona, these are the the very low energy requirements, so that's why speed is high. And again fourth generation, the speed is very high. Consensus mechanism: what is the purpose of consensus? To approve the transaction or block. Proof of work: the principle is too difficult to solve but easy to verify. So here in proof of work algorithm or consensus mechanism, we solve the mathematical complex problem to approve that transaction, to find out the nonce. Process: new nodes created by solving complex problems. Suppose new node or new blockchain is added. So in order, if that platform is following the proof of work, then each node they need to use the previous hash random number and the information available to solve that equation. Once you solve it, then you get the basically the correct answer. Features: computer intensive, huge, you need huge amount of memory to solve those complex problems, because you see the hash ID, it is very complicated and you need to find out what is inside into that hash ID. It requires significant power. This is your proof of work. So in initial generations like your blockchain, Bitcoin, Ethereum, they use the proof of work, but now some other consensus mechanisms are there. Proof of stake: principal validates stakes Ethereum. ETS means ETS to participates. So here in order to participate into your decision making process consensus mechanism, you need the minimum ETH. ETH means Ethereum, minimum 32 ETH to become a validator in that proof of stake. Process: validators randomly selected to create and validate the blocks. Then third one was the delegated POS. It is similar to the proof of stake, but it it follows the election system to select witness nodes. So it follows some witnesses. It doesn't consider all the the validators here. So that is why delegated POS. Process: witnesses verify blocks instead of all validators. So in delegated, only selected members nodes they will participate into the consensus process, not everybody involved into that mechanism. Proof of elapsed time: so it is based on the random waiting time for mining rights. So process: first node to finish waiting gets to commit the block. So first node who finish the waiting, they are able to commit the block. So these are the only couple of consensus mechanism, but if you look at some advanced literature or recent literature, you may find some other consensus mechanism as well. This is also the based on the recent research article. Blockchain versus traditional database. So characteristics: traditional database, client server. Here peer to peer. Authority in traditional databases, centralized. Here distributed, decentralized. Control in traditional one, administrator, your bank, government policy. Here public, permission, hybrid. Disintermediation, data is centrally administration by the DBA in traditional. But here trustless and decentralized, no need of intermediate to validate and authorize to store the data. You don't need any third party to approve or to authorize the data. Robustness, here single point of failure. If your main server is down or crashed, your whole system will be affected. Here no single point of failure or control. Audit trail of all the data instances. Here history of records, ownership of digital record not available, data can be updated and modified going back. But here history of records and ownership of digital record is available, data is traceable to its source. You can trace from where that product started its journey, who are involved into those journeys. A new block added to any new addition or modification. Data handling, data storage. In the traditional we store the data in tables, but in blockchain we store the data in blocks. Public verifiability, data integrity is lower. Here transparency is maintained. Again here transparency, database administrator decides what is visible to the public. Here public blockchain supports data transparency. And then data persistence, non-persistent in traditional databases, and blockchain it is immutable. Blockchain platforms, Bitcoin is the very popular and famous blockchain platforms. The type is first cryptocurrency based on the blockchain. Bitcoin consensus, it uses the proof of work. Architecture single chain. Programming you can do in C and other languages. Ethereum another platform. Open source platform for smart contracts and decentralized apps. Network public and open source. Programming support solidity. Features faster processing and private transaction within the permission groups. So there are many platforms are available, like Hyperledger is there, open source, cross industry blockchain platform by the Linux. Use cases: finance, banking, manufacturing, you can use the Hyperledger technology or Hyperchain platform. Components include Bureau, Fabric, Grid, Indy, and so on. Hyperledger Bureau, permissioned modular blockchain client. Features. Now it's time to learn how exactly blockchain works. I need 7 groups. So you distribute whatever you want to 3-4 students, but I need 7 groups, no more than that, and no less than that. 7 groups, and make some distance between each group, like at least make some one keep one bench distance from your nearest bench. Why I am saying keep the distance? Because I am giving you some confidential data. Okay, confidential data, that is your private key, it is your blockchain wallet. Okay, so if other team, if they see your blockchain key, then it will be problematic for you, you would lose your asset. So that's why I am saying that I need 7 groups. Can you come from this first column in this side? You can sit onto the one bench, that's fine. 7 group. Yes. Yes. Where is the group 1? Sorry? It will be varied. So don't worry. There is no requirement like 1 or 2 students. Yeah, that's fine. Group 1, group 2, where is group 3? Make some distance, because if I give you the key and if the next group, if they see your key, then it will be problematic for you. That's why I'm saying that the second row you can come forward on the first keep some distance between two groups, so that the other group cannot see the private. Come front, the second row. Come here. So this blockchain game, it was designed by J. Scott Christensen's. So he is an associate professor at Missouri University in the US. And the purpose of this game is to understand basic stuff. How does blockchain works? First group, second group, third group, girls, two girls. Can you? No, otherwise you go there. Whatever it is. First, second, third. This is fourth group. Two people. Fourth, fifth, sixth. Again we need more people. We want 7 students. You do one thing. Four of you to make the another group. Go back. Yeah. We need minimum 7. Minimum or maximum, exact 7. Join in somebody. First, second, third, fourth, fifth, fifth. Which is sixth group? That is, this is first one, this is second, third, fourth, fifth, sixth, seventh. Again, you are filing this way. Make it another. So two, you come here. 1, 1, 2, 3, 4, 5, 6. Last two students, you are seventh group. Okay, you can sit onto the one bench, because you need to solve the problem here. So you need to work together in a group, and you need to solve the problem, the mathematical equation. The group who will give me the answer first, that will be the winner minor for that one. Okay. So blockchain basis, we know distributed ledger, no central server or authority. Everyone as a node, as a known as node on the network, has a copy of the ledger. So each person, each team has a copy of the ledger. A huge variety of information can be stored on a blockchain ledger. Huge, it's not like only limited information. You can keep huge amount of information on blockchain ledger. Distributed ledger can store financial transactions. All the transaction happen in last 1 month, 1 year, you can keep there. Property records, shipments and inventory. In fact, you can keep the grades as well. Nowadays, sometimes if I am a teacher, I mark your answer scripts and I send the grades to the central registrar or registration system, where they keep the records of all the grades. Why do you send the grades there? I can keep the record of the grades, and it is transparent, safe, and secure. So we are going to see how this blockchain will work in the grade system. Suppose I want to store the grades in blockchain, okay, and you want to, I will give you the keys, the block, and then we will see how we can make the blockchain of that storing the grades. Distributed ledger for grades, all teachers calculate student grades and then enter to the grades into a central repository. So this is your traditional approach. Why not eliminate the registrar? Why do you go and store there? Why don't you keep the local copy, which is tamper proof, the unchangeable? Just have the teachers maintain the ledger of grades. Let's try it. Everyone in the class will act as a special nodes called minors. So we have got the 7 group here, and you are the minors nodes. I will pick up 7 people to be students, means we are instead of 7 students, I am saying the 7 groups. Student identities are concealed. Each student has a public ID that matches with a private ID. I will give you the IDs, your public ID and private ID. So public ID will match with your private ID, that only the student knows, and you only knows that private ID and public ID. So first is fine. Why? Where is first group? This is your copy. Keep it confidential. If you lose it, that is fine. That's fine. Public. Because first basically block we are trying to create is the census This is your second. Third one is what is written on that one. There is a one public key and there is a one private key. So don't worry about this one because for first block everybody knows what is the public key and what is the private key. So your group number 4. Keep the copy of this one. Group 5. Keep the copy of this one. Group 6. Keep the copy of this. Group 7. So you have got one public key and private key on your student ID. So now we want to create the blockchain to store the grades. We want to create the blockchain to store the grades. So here you can then use any of the grade scanning tools to review the blockchain, retrieve your grades. Okay, this is your public key and private key. So this is the first block. Course parks. Okay, let me. I forget to add. You need the another block as well. Blocking information. This is common. This is the tool or the page where you create the block. So block 1, course is Sparks 370. This is the name of the course. Student is AD59DA. What is the grade? Fail. Grade is fail. So now we want to create the block for this information. So you have got two basically copies. One is your key, private key, and the public key. And this is the second table, basically, the where you create the block. Okay. So what is written there? I will show you. Let me show. Okay. So this is your first block. Okay. So basically, let me show you a bit. So this is your student handout, okay, and you can see some information there. So block, we have got the we need to create the blocks based on the courses. So we have got couple of courses available. Student ID is given, grade is there. I will tell you what is the grade. What is this NOS? What is this NOS? Random number from 1 to 3. Okay, A, B, C. What is that? I will tell you. Value of, and then this next column is value of last 2 digits of previous hash. This is the previous hash, and the value of last two digits is 1 2. We are taking that 1 2 here and divide the number. So how do you calculate the hash here? You take the this A, the number. What is A? Value of the first letter of the course. Value of the first letter of the course. So tell me, what is your first course? Park 320. Then what is B? Value of the first letter of the student public key. So you have got the public key and private key. Now use that public key. What is the first letter of that key? Then go to this lookup table, find that first letter and take the relevant corresponding number. C is the value of the grade. Again F, where does it come? F is 70. So nonce is the value between 1 and 3 that you will adjust to calculate a hash that can be equally divisible over 3. Now add the, use your pen and tell me what is the the information for this first block. How do you do it? Tell me. Course is, yeah, Park 320. Write down in your student handout note. Course is Parks 320. What is the student ID? What is the student ID? Depends on the group. Depends on the group. So student ID for the first group, we know the student ID. Student ID is AD59DA. For block 1, this information. Why I am showing this information? Because block 1, the information is available to everybody. That is called Genesis block. If everybody there, if they are not aware of that block information, how they can make that block? So what do you do? Tell me the number now. Do the calculation. Student, you know, grade, you know, A, B, C, you know the value of the previous hash. The team will which will tell me this hash, that will be the winner for this block. 207. Okay, we got one answer, 207. We will decide rest of the 6 groups. 207 is correct. 207, that number is should be divisible by 3. This is the requirement. Whatever the hash you are creating, that number should be divisible by what? 3. So we got one answer, 207. What do you think, rest of the members? Notes. Do you want to agree this one? Do you want to approve it? Come on, guys. You know the student number, you know the grade. Select the nonce, the random number. I am just asking for first block. Don't do it for the whole thing. Okay, so 204. Listen here. Stop your calculation, guys. Listen. Stop your calculation. The first team said that what 6 number 207. Do you approve that one? No. Okay, you are saying 20. So first team said 6 number 207. What else? Raise your hand if you approve that one. No, no. Raise your hand if you approve that 207. There is nobody is approving your hash. Okay, that's cancelled. The next one. 204. How many of you approved it? The rest of the 6 team. The answer is 204. He is saying. The rest of the team approve. Raise your hand if you approve that hash. 204. Come on, team number 7. Do you approve the 204? No, you don't approve it. Okay. What about team number 6? Do you approve it? It's very easy, guys. I don't know why you are taking so much time. So you know the A value of the first letter of the course. The course is Park 320. So what is the letter? Park. P. 80. 80 will come here. B means value of the first letter of the student public key. So whatever the public key, what is that public key for student number 1? Public key A. So A, in front of A, 65. 80 plus 65. What is C? Value of the grade. What is F? F means 70. So 80, 65 plus 70 minus 12. Minus 12. Then you need to select the random number from 1 to 3. But whatever the hash you are getting, that should be divisible by 3. So somebody said 207. So is it divisible by 3? I don't know which random number did you use. Did you use 1, 2, 3? 3. So you said 3. Then how did you get the basically the 207? By putting all those information. So do you think that 207 is correct one? It is not correct. Then what is? So 3 he has selected. Who has selected the 2? Random number 2? Has anybody selected random number 2? No. Then you selected 3. Oh, sorry, 1. 1. So when you add the select the random number, when you add this, the number you will get 204. That is divisible by 3. So let me show you here. This is your first block. 1 to 3. You want to randomly select it. 1 to 3. What? 1 to 3. From 1 to 3. Random number should vary from 1 to 3. But you want to select such a random number, the whatever the hash is coming, that hash should be divisible by 3. Okay. So course is Sparks 320. Student is AD59DA. Grade is 5. Miners will solve a puzzle to create a unique number of the block. That is a hash using the information contained in our block, and they use that to make our ledger secure. First to generate a correct hash wins. So you generated the correct hash. So you are this first group. This is the winner of that first block. This is the winner of the first block. Other miners and node will verify if that hash is correct. When that 6 number group said 207, I asked you whether you approved of it. Okay. So if majority of the people approve it, then we take it as is. But sometimes again you need to make sure that that is what they have done, whether it is correct or not. Suppose if that 207, it is a wrong hash, and if majority of the people will approve that transaction, what will happen? You are entering the wrong information. You are entering the wrong information. Why? Because 207 is not the information for that, whatever the data is given. So hash, it represents the information given in that block. If wrong hash is generated and if nodes approve that hash, what happen? Blockchain will not work. Got it? So the correct hash, you need to approve it. Other miners and nodes will verify if that hash is correct. Now do it fast. Has everybody understood it, or shall I repeat it again? Answer I will tell you. Answer is the nonce random number is 1 and the final hash is 204. Random number, you put all 2 3, but it will not get that number that will be divisible by 3. You can do it. You can put the random number 2, you can put the random number 3 and do the calculation. The number, the hash that you are getting, it will be not divisible by 3. So 204 is the correct hash for that blockchain, for that initial block. Now this is done, basic stuff. Now you have got additional 6. Now do fast. Have you understood it? Now it's time to make it fast. Now I will tell you the student ID, the code and everything, and what you want to use in from the previous block. So here 2 and 2. So last last 2 digits will come here. So now what you have got here, hash, what is your hash? 204. And what is the last 2 digits of that hash? 04 will come here. And now I will tell you the course, student and grade. Then you need to do the calculation and you tell me the hash. Once I get the first hash, the rest of the members, they need to decide whether that hash is correct or not. So whenever we get the hash, stop working and approve or reject that hash. Got it? Shall I show you the second student and the course? So this is the basically the information about the first one, value between and lookup table. First block 80, 65, 70, 12. When you add the random number 1, your hash is 204. Okay. So last digit is 04, means 4. So that 4 will come here. Now we want to create the second block. This is your second block, and tell me the hash now. Do it fast. New block, the group number 4. Look at this one. New block. Course engineering 300. Student ID this one. Grade is this one. Tell me the hash. 198. Rest of the group, stop your working. 198. Is it correct or not? 198. Is it correct? Approve it or reject it. Each group. Approve it. What happened? Approve. You haven't done the calculation. Group number 4. You have got the answer here, 198. Is it correct or wrong? First group. Is it correct? What is the random number you used? 1. So majority of the members nodes, they approved that transaction, means that is correct one. Look at the second block. This is your course, student ID, grade B, random number used 1, 69, 66, 66 from that lookup table, and the last digit is 4, and the hash you got 198. Why you are taking so much time? What is difficult here? Sorry? 204 for the second hash. Why is it coming 204? Did you use this last digit 4? Did you use this last digit? You can try. You can place the 1 first, random number, then 2 and 3. Whatever the number you are getting here, that should be divisible by 3. If 204, how does it come again 204? Do the calculation. 69 plus 66 plus 66, then plus this nonce, then minus 4. Value of the B will be 0 all the time. Not public ID. For ABC, you need to look at this table. For ABC, you need to look at this table. Look up the table. Got it? You need to look at this table to get the values of ABC. This is your lookup table. Done? Now we want to create the third block. Got it? Shall I tell you the course and student ID? Do it fast. Are you ready? This is the block 3. Business 200, student C64445, grade C 102, 105, 105. Yeah. Are you approving 105, guys? 105, is it correct? Approve or reject it? They corrected it then they corrected it. 105. What do you think? I think fourth group is struggling little bit. What's happening? 200? 1. Okay. So here we got 105 and 201. 201. What is the majority here? 201. 201. You what? 6 105. So raise your hands who is approving the 105. 1, 2, 3. What is third group? What's happening? Third group 105. You just need to look at the letter first. Business group, then student group C, B plus C, then grade C, again C. 105. 105. Then first group, what happened? 204 you were saying, am I right? 201. Okay. So third, our block is business 200 course, student IG is C67445, grade is 7, nonce you can see 3, ABC value previous block from 198.98 and new hash is 105. Done? Has everybody got the answer? Now next, shall I share the next information, next block? Ready? Course number 4. Parks 320, student is different E2 DD8A, grade is B. 213. Okay, 213. How many of you are approving it? 213. 213. Approving it. One team is approving. Two team is approving. What else? 213. Approving. So 3 team. 213. Okay, so 4 team approved the 213. So that's your correct answer. 213. You can see the previous hash is 055. Then you have got this ABC 80 69 66. Random number you used 3. And then you got 213 which is divisible by 3. Shall I tell you show you the next block information, or is there anybody who hasn't done? Group number 5, have you done? Block 5, do it. Engineering 300 E2 DD88. Somebody told me 195. 195, 195. How many of you are saying 195? 195. Okay, good one. 195. What is the last group? 7 number group. Are you doing it? Are you following me? If you are struggling somewhere, just let me know. I can repeat it. 195. 195. 69, 69, 68, 13. 195. Then last digit, last course. This is the block number 6 information. Engineering 300 BD 7AF, grade is B. Tell me the hash. 107 108 108 108. How many of you? 108. Okay, 3 groups. 108, 4 group. 108. Yeah, so that's your final answer. 108. So tell me how it is how these blocks are interconnected, because we are using the hash from previous number. So this is just for the demonstration purpose. This is the your basically the for the simplicity purpose we use this hash. But if you look at the real hash, it is very lengthy. As I said, you can basically see the 16 times 18 times 0 in front of that hash, and then the additional information is available there. Suppose I am easily corruptible. So one of the student number 1, AD59DA, that student want to bribe me to make that change from F to A. Can we do it? Now transaction is done, completely done. Now I want to make some changes here. As I said, I am easily corruptible. If you give me the 50 pounds, I can pass in that module. The student number 1, I can change from F to A. What will happen if I change that F to L, F to A? Everything will be changed. Let's see now. I will show you the Excel file. What will happen if you make that changes? So this is my course name. So I have given you only the 6 course, the student ID, the grade, this is a random number, this is a previous hash. Previous hash is our first hash is 212, previous hash is 12 ABC, and whether it is divisible by 3 or not. So everything is showing green, means that all the hash they are divisible by 3. Now as I said, I got the 50 pounds, 500 pounds from this student number 1, and I want to make the changes now. I want to convert this F to the A. Let's see what happens. So you can see that. Now what happened? Everything is affected here because of that. Nothing is working here. So this is the basic principle of blockchain. If you recorded all the information and then you try to make the change in the recorded information, all the hash, whatever the the code is there, blockchain blocks you have created, everything will be affected. Okay, so that's why we are saying that it is a transparent secured information and we cannot make any changes in those transactions. So if you want to see the exact basically the blockchain information, just let me see. So this is one. So if I want to ask you, what course did C6745 take and what grade did they earn? Look at your table. Tell me what courses did student number 67455 take and what grade did they earn? Business C67, student ID C67, business 200, and they obtained the grade C. So all the information is available to the all the members. They can find that information. Student 2, what grades have they received? Student 2, they received the grade B. So those kind of information we can get from this your blockchain. Then what if we change the block 1? As I said, Parks 320, we changed from the AD from grade F to A. A grade is announced by someone other than a faculty member. Suppose, as I said, I am not aware, and if somebody announced that grade, student pays up a node, any node, to record an A for their grade. Student's private key is also lost sometimes. So again, whatever the key you have got, that is a private key, and if you lose that key, it will be difficult for you to find out the hash. A miner changes a transaction and announces that hash to the network before anyone else calculates it. The difficulty of calculating a hash increases as the blockchain grows. When your blockchain grows, the difficulty of finding that hash, it will be increases. So here let me show you the you can find out the this information about this game. So this is the website from where this is a J Scott. He is a associate professor in Missouri University. So you can see now blockchain explorer. So if you want to see the exact hash and how it is developed, so you can see this is the bitcoin.com website, and you can see the the Bitcoin, and then you can see this is the, it is continuously updated. So this is a hash ID. Can you imagine how it is difficult? So I gave just one example of, but this hash ID is created using the previous information, the available information during that block, amount, fee, from which customer it is going, from where it is doing, hash is, so many important information is stored into this one. So this is just one example of how you can keep the records into the blockchain, and then how you can make it transparent, tamper proof and all those things. Then if you want to see some other latest transactions, let me see. So you can see average transaction time. These are the blocks continuously updating. Unconfirmed BTC transaction. Unconfirmed means they are not approved by the nodes. And this is a wallet. Then you can keep your Bitcoin there. And then let me show you the something else. This is a Etherscreen, again Ethereum blockchain, another platform. You can see the latest block here. Okay, so Ethereum price, miner, who is the miner that found out these blocks, and then you can see latest transaction, and when you click on this one, it is still loading, you get the hash ID. View all blocks, view all transaction. Sorry. So number of blocks. So good or not, it depends on the the network that you are seeing. Suppose you are involved in the supply chain and you are only talking about supplier, manufacturer, distributor. Who are the parties involved in that supply chain? Accordingly, that. So yeah, this. So yeah, I gave you some table. I discussed one tables like first generation, second generation. Bitcoin is there, Ethereum is there, some other platforms are there. So it depends on how much information you are getting, what you want to do, how much the energy you require, the computing power. Based on that, you decide. So basically, the basic the fundamental or logic behind the blockchain is this one that we discussed today. But again, as soon as you add the the information into the blocks, all those blocks are interconnected and nobody can go back and change the transaction. Okay, so depends on the I will explain the basically one case study as well, IBM's blockchain, how they use this blockchain to to do the traceability of the food supply chain. So blockchain game is done. So blockchain applications in supply chains. So logistics and supply chain, tracking and tracing of the raw materials. So with the help of that hash ID, you can track and trace what is there in that hash ID, how much material you are getting, raw material, finished products from inception till it reaches to the end users. Significance, shipment tracking. You can very easily track the shipment. Transparent processes, all the members they get the updates about this shipment. Dispute management, why is it important, why blockchain is important for dispute management? Because you have got the the records, and that is tamper proof. If somebody is not or taking the responsibility, or somebody is denying the accountability, we can very easily do manage that dispute management with the help of this tool. Inventory monitoring and management and payments. These are the some of the examples which blockchain you can use. Mux, SIP chain, or AOG. Challenges: high implementation and operational cost, not feasible for smaller organizations. So smaller organization, they need the huge amount of investment. That's why sometimes the implementation of these blockchains are difficult. Healthcare and pharmaceuticals: securing health records, secure private storage and sharing of electronic health records. Sometimes in healthcare sector, you need the confidential information, and you want to transfer that confidential information securely with the other members. You can use the the blockchains. Like here you can see genomics or mediculture. In tamper-proof data ensures traceability and non-repudiation for health records. Counterfeit medicine prevention: you can use this blockchain for the counterfeit medicine prevention as well. Okay, why? If suppose somebody is we are making the digital record of each transaction. If somebody has done the transaction, and after that transaction, if somebody is trying to make the changes in that transaction, it is very difficult, you cannot do it. But during traditional way, during COVID-19, you might have heard that. What is that? What was that COVID the medicine, remdesivir or something, it was that. So many fake medicines were there, and this kind of incidents you can avoid with the blockchain. Tracks and traces medicine in the supply chain. Another one very good example of how blockchain can be implemented in logistics. I told you the beef horse meat scandal in the UK in 2013. The food authority in the UK, they did some random sampling of the sandwiches in some couple of grocery stores. So what they did found, in the expensive beef sandwiches, when they did the DNA testing, they found the DNA of the horse meat. Okay, and they did the then proper investigation. So many the sandwiches were contaminated because of that one. When they started the investigation, what happened? The Tesco, all those major players, they said that we brought the basically sandwiches from one of our supplier. Okay, then when you go to that supplier that we used our third party to get that the chicken beef from somebody else. So it was so complicated. The network, the members, they were in from the UK, from the Europe and other parts of the world. So when they started investigating, everybody was saying that we didn't do this. We exactly send the products whatever customers want, whatever the retail was. We didn't put that the horse meat in the expensive beef products. But again, suppose you are exporting some food items from the India to UK. How do you make sure that the quality of that food is great, it's good, and you are saying that it is organic one? Okay, sometimes you say organic and non-organic. How do you make sure that the food that you are sending is the organic one? Because the people, retailer, those who are taking the food from you, so they don't come here. So normally some kind of certification, insurance you need to follow. You need to approve those the transaction, the certification body, the insurance body, they will do the check here, then they will approve that this is a really organic products. Then it goes to the other member logistics provider, they pick up the products, they send to the other members of supply chain. So that traceability you can very easily do with the blockchain. Health supply chain counterfeit, drug detection, finance and insurance management, patient data, so many things. And these are the some of the examples of this supply chain. And you can see basically what are the challenges in this area. Lack of standard data capturing and sharing procedures and mechanisms, data ownership and privacy issues. Food and agriculture, reducing the food wastage. How could you use the blockchain? So if you want to reduce the food wastages, you can get the up-to-date real-time information from the blockchain. What is the expiry date, from where it is coming, all those things, and you can avoid then food wastage. Improving food supply chain, tracking and tracing of food from farms to households. Okay, so nowadays with the help of blockchain you can track from who are the your basically the farmers, from which farm that products you are getting. Significance, traceability of food supply chain, quality control, payments, logistics. Challenges, absence of standard rules and regulations. Again, we need some standard frameworks to run this blockchain. Lack of technical know-how, digital divide. Transportation, logistics, tracking and tracing. So The IBM's blockchain, they the Musk used to track and trace the containers they were transferring, fuel monitoring, providing equitable opportunity for big and small transportation players. And significance, you can do the autonomous vehicle monitoring and management, road safety, payments. Again, challenges: high implementation and operational cost, non feasible for smaller organizations. Blockchain in supply chain, this is a very famous and classic case study of basically how Merck's collaborated with the IBM to track the shipments of their containers. Do you know the Merck's? This is a container shipping company. Background: Musk, the world's largest container shipping company. The current contribution, the share is 18 to 20% of market share. They faced the challenges in tracking shipments and excessive paperwork in international trade. When you transfer those empty containers, or when you move from one port to another, from one port to another port, from one country to another port, there is a huge amount of paperwork involved in that one. Okay, because once that containers reach to the ports, the custom clearance is there, and if suppose you are moving the perishable goods, because of that time delay, the your goods may be spoiled. So IBM proposed a blockchain based solution. It's called trade lanes platform to streamline their logistics, basically the tracking shipments. What were the problems they faced most during global shipping? Paperwork and overload. Each container required stamps and pay approvals from up to 30 people and 200 plus interactions. Imagine, just for one container you need the permission approvals from the 30 people, and then 200% interactions, and you are doing all these manually. You are going to those 30 people, you are taking the stamp, you are doing their signature, all those things. So it is unnecessarily increase your cost, time, all those things. So Musk wanted to streamline this process so that they can very easily move the goods from one port to another ports. Delays and inefficiencies: containers could be held at ports for days due to missing paperwork. One of the paper is missed, they cannot allow that container to the other network. Fraud and security: bill of lading, again they can tamper the bill of lading, were often tampered with the copy, leading to billions in maritime fraud. So these were the problems Musk was facing. So then they collaborated with the IBM to make that trade lanes platform. You can check, they have got the website as well, trade lanes platform, and you can see how they solve this problem. Key features of that trade lanes blockchain, which was built on Hyperledger Fabric platform: real-time tracking, GPS location, temperature, shipment condition. GPS tracking of each container, what is the temperature inside that container, what is the condition of shipment, everything they can track from their location. Immutable digital records, so basically prevents the tampering, forgery, or fraud in those digital records. Instant document verification, custom authorities upload approvals digitally, reducing delays. Nowadays, because of this advancement technology, custom authorities, they can get the digital copies of all the paperwork with just in a fraction of minute. They can see all the information and they can approve it. So before you go to that, you take your the container to the customs, you can well in advance you can upload those documents, and the custom authorities, they will approve it. Increase the transparency, all stakeholders, Musk, customs, port authorities, logistics provider, they have access to this real time shipment data. So they initially started the proof of concept. They did some test shipment flowers from Mombasa, Kenya to Rotterdam, Netherlands. The shipping cost was involved 2000 USD. Paperwork cost was 300 during normal time, 15% of cargo value. The results was they reduced the paperwork because of this blockchain. Handling time ensured the secure document verification, because as we have seen in this blockchain game, they cannot change the record of that digital transaction, because it is linked with the previous your block. Okay, so they cannot make any changes in those digital records in those blocks. Increase the trust and transparency between trade partners. So this is the example of Musk and IBM. Then they did the pilot project. This was the initially the initial study, and then they did the pilot in 2017. They sent the Schneider electric container from Lyon, France to New York, US via Rotterdam. involved authorities. They involved the Netherlands Customs Administration, US Homeland Security and Customs, Maersk Supply Chain Company, Damco. Goals are track end-to-end shipment, test blockchain's efficiency in reducing custom clearance delays, and ensure the compliance with cross-border regulations. You can do the end-to-end tracking with the help of this blockchain. It reduces the custom clearance delays, time, and so on. Results: reduced the paperwork and processing delays, eliminated fraud risk with tamper-proof documents. So bill of lading during earlier cases, it was easily it was the people were easily changing the bill of lading. So that's why, with the help of this blockchain, they couldn't do that changes in the bill of lading. Improved supply chain visibility and efficiency. So all the members like customs, then the IBM, the Maersk, they got all the updated information about this supply chain visibility and efficiency. Enhanced the trust among global trade participants. Production launch planned by the end of 2017, and after that they expanded the trials to other products as well, pineapples and oranges from California. Any doubts in the IBM Maersk case study? The platform is available online. You can just search online. You can see what kind of blockchain they have built up. Another Provence case study. This is a startup company from the UK based blockchain startup. They wanted to do the track the basically the fish that the UK were buying, procuring from the Indonesia. You can see the link of that case study as well. Industry: fishing and seafood supply chain. So Indonesia is the major supplier for the the seafood. So the project, they started pilot project in Indonesia 2016 to improve the traceability in the fishing industry. So they use some sensors, mobile phones, blockchain, smart tagging. These are the technologies they used for that traceability. Challenges they faced in earlier case fishing industry: lack of transparency. Seafood sourced from hundred of boats, making tracking difficulty. Suppose you are sourcing that seafood from hundred of boats. How do you make sure that which is a good quality seafood and from where you are sourcing that seafood? Similarly, suppose you are exporting some coconuts or grapes from the UK, from the India to the UK. How do you know that which is a good quality grapes, which is a bad quality? By the appearance, you cannot tell that. Suppose I want to find out organic and non-organic. How could I find out that? So that's why there is a lack of transparency, and we could use this blockchain to improve that transparency, visibility. Quality control and sustainable claims are often unverifiable. Quality control means I could claim that my grapes, my products are very good in quality, they are organic, I haven't used any chemicals. Sustainability claims, we can say that my product is sustainable friendly, I haven't used any non-sustainable products, all those things. But who will verify that information? So that's why you need the blockchain. In the blockchain, some certification players are there, insurance players are there. They will check whether this product is really organic or not. Once that player will approve that, only then only the products will deliver to the next member. Fraud and overfishing. Illegal, unreported and unregulated fishing is widespread, because nowadays consumers, they are become very aware, and they want to know that how the suppliers, how the manufacturers made these products. So they want to check the environmental impact of their products as well. So fraud and overfishing, illegal, unreported, unregulated fishing is widespread in Indonesia. Counterfeit seed feed and mislabeling lead to consumer deception. Suppose your fish is not good quality and you are labeling it is a very good quality. How do the retailers sitting in the Western country, how do they know that whether it is a really good quality of seafood or not? Those kind of problems. Corruption and human rights issues. Again, bribery and fraud in the yellowfin tuna industry, reports of forced labor and slavery in the Southwest Asian fisheries. So these were the some of the challenges this the seafood industry experienced, and that's why they developed the blockchain with the help of mobile phones, sensors. How it worked? Tracked the fish from catch to consumer using mobile phones and smart tags. So when you apply the smart tag, it will tell you from where this the fish is sourced, how it is transferred from one node to another node. Immutable digital records ensure transparency and prevented fraud. So here you can find out the accountable people as well. If suppose I am the fisher, I source the fish from the the sea, and then I got two kinds of fish, good quality and not a good quality, and I am claiming that not a good quality, it is still good quality, I am mentioning it, I am claiming it. Once that product reach to the retailer, and if they found that I am selling the non-quality, good, not a good quality fish as a good quality, they will blame me. They know that you are the person who is responsible to make that claim, and now you should be penalized for whatever the claims you are making. So that accountability you can get in these records. Smart contracts verified sustainability claims and prevented data manipulation. Enhanced accountability for the fishing companies and authorities. So as I said, if some company is claiming that they are doing this sustainable business, their quality of the food is very good, how do we verify it? If something is not correct, then you can hold them accountable. Impact and results. Track the seafood supply chain for 6 months in Indonesia. Then what they did, first successful blockchain based seafood traceability system they developed, increased the consumer trust by providing verifiable sourcing data. Consumer trust, suppose if I get the information of all the information of that seafood, from where it is sourced, how it is transported from the Indonesia to the UK or some other parts, who are the what was the temperature when they transport those things, how they sourced those seafood, and whether they used any child labor or any other things. So those kind of things will be available with the help of this blockchain, and that helps to increase the consumer trust. Potential to stop unethical practices including forced labor and overfishing. Okay, so when you declare that you are not following all the ethical practices, you need to make sure that as well you are not using any child labors or overfishing, all those things. Future potential application of this blockchain. Largest tuna producing country, ideal for scaling blockchain solution. So you can extend this, scale up this blockchain solution to other the tuna producing country. Southeast Asia provides seafood for over 200 million people. Major industry impact, if everybody uses this kind of blockchain technology, so the whole transparency visibility will be improved. 90% of the seafood in the US comes from the Southeast Asia, and now they want to check all the traceability of this supply chain, so they can do with the blockchain. Commercial launch could eliminate illegal fishing and unethical labor practices. So you can see here one example of how the workers, they are taking the pictures with their mobile phones, with the whatever the digital tags are there. Modem and pharmaceutical supply chain, another famous example of how we could use your blockchain to avoid the counterfeiting in the medical supply chain. So they wanted to ensure the safe delivery of pharmaceutical drugs by tracking the environmental condition. If you look at the COVID-19, you need that -70 to -80 degree temperature. How do you make sure that during the whole journey that temperature is maintained? So you can do that analysis with the help of blockchain. It will also tell you how much energy they consumed while maintaining that temperature. Challenges: medicines require specific temperature, humidity and light condition. Compliance with the European good distribution is very costly. Again, the Western countries, their compliance rules and regulations are very strict, and in order to deliver them, you need to follow them, and then that is very costly. Cold chain logistics are 4 to 8 times more expensive, leading to 3 billion in annual waste. Cold chain logistics, why it is expensive? Because of the requirement of the cold chain, you need the the huge amount of energy to maintain that cold chain environment within your supply chain. So that is very expensive compared with your normal supply chain. So Modem's blockchain solution, what they did, they use the smart sensor track the shipments without costly refrigeration. Okay, so you don't need to invest into the huge costly refrigeration, rather than you go with these sensors which helps to track the shipments. Data is stored on the Ethereum blockchain. The Ethereum blockchain second generation validated via Solidity smart contracts. If conditions deviate, conditions means the condition of that medical products. If it's deviate, automatic alerts notify sender and the recipient of that shipment. Pilot project they started in June 2016 to test the real-time monitoring and compliance automation. Walmart and food supply chain. Walmart used the blockchain for what purpose? To track the food from farm to fork. Objective was improve the food safety and traceability by tracking the pork in China and the produce in the US. Challenges: manual tracking took days to weeks to trace the food origins. If you start doing the manual tracking of all those products, pork and produce, so it takes huge amount of time and huge amount of cost. Okay, so what happens, guys, if there is some contamination happen in the food? How do you recall that one? Suppose in that horse meat scandal, when they found that, they did the recall of what? All the affected products. How do you know that out of whatever the products you sold, which are the affected products and which are not the affected products? How do you check that? You recall the whole batch. Okay, so but in that batch as well, maybe some the products might be contaminated, some products might not be contaminated. Small, but again you are doing that whole the sample whole lot you are analyzing. So block, yes, good. In blockchain, you know that who supplied this product, contaminated product. Rather than recalling the whole lot, you can find out who made this lot, from where we got those lot. You can go to that respective corresponding entity and you can discuss with them. Okay, so here that is the benefit. Contaminated food recalls were slow and inefficient during the normal time, but blockchain, IBM powered blockchain tracks farm, batch number, storage, shipping, expiry date, everything. Nowadays, if you are taking the products from single farm, it will tell you that which farm they used to for this crop, which logistics provider was involved, storage, where they stored the product, shipping, expiry date, everything. Tracing time reduced from weeks to 2.2 seconds. Look at this one. From weeks, they reduce that tracing time to 2.2 seconds. This is very huge, development, I would say, because reducing the tracing time from weeks to 2.2 seconds, it is a significant achievement. They used other RFID tags, sensors, and barcodes for real-time data collection from the farms, logistics providers, and other members involved in the supply chain. Benefits: faster identification of contaminated food sources, preventing mass recalls. You don't need to the recall all the products. Have you heard the Volkswagen the diesel scandal? Volkswagen company, the Germany company, Volkswagen emission scandal. Does anybody aware of that one? So Volkswagen, in order to show the lower emission in the US market, what they did, they used some device in their car, and when they do the testing, when you done the testing, when you go into the onto the road, that device will get turned off. Study, Volkswagen lost billions of USD during that case. It happened, I think, in 2005 6, and it was not essentially did that one so that they can get the good sales in the US market, because the regulations were very strict in the US market for the lower emission. Recall, all the Volkswagen model they made during that time, they recalled all the models and they made the changes in that one. They customers who bought that car during that time as well. So sometimes what happens, you can use blockchain technologies to members has done this activity intentionally, so you can, rather than recalling the whole lot, you can go with the selected products. Authenticity. Walmart filed a blockchain patent in 2017 for package authentication and drone delivery. So what they did, they partnered with the Auspost, Blackmores and PwC to combat the food fraud, developing a blockchain based food trust framework for supply chain integrity. Food ensures the traceability and authenticity for food products. Another example is the Lockheed Martin and supply chain security. Risk management. So if you want to manage the unexpected events, you can use this blockchain. Uses blockchain for secure, tamper-proof and data. Then another in pharmaceutical tracking, collaborated with the Link Lab to launch a blockchain track and Supply Chain Security Act, and then enhances the drug authenticity and prevents the counterfeits in USDR. So what is the role of blockchain then in supply chain performance? If you look at the supply chain performance, your cost. In Maersk and IBM case, we used the blockchain to reduce the paperwork, to reduce the cost, to reduce an administrative cost, enables the strategic removal of defective products instead of mass recalls. So during the recalls, you don't affected products and you do that strategic removal. It optimizes the resource allocation for shipping and logistics. Additional digital records, it helps to lowers the your regulatory compliance cost. Mechanical records and smart contracts for process automation. So these are the some of the impact of the blockchain on the administrative cost and what kind of mechanisms we can use IoT. I think in our last session I told you that 5.0 technologies, they are integrated. Okay, you cannot use them in isolation. Like for block connectivity technologies as well, IoT, Internet of Things, you need the blockchain to transfer that information, to track it. Physical processes and interactions. So during the normal paperwork, it takes huge amount of time, speed. So digital record, we can reduce the time there, reduces delays caused by the missing documents. For one from 30 people, if one of the documents is misplaced, the your container will be held at that holders. Then mechanisms, IoT sensor for tracking temperature, humidity, movement. During that tracking humidity, digital audit trials for fast verification, we could do that. Ensures the accurate measurement of product quality and authenticity. So suppose your suppliers are saying that these are the can helps you to certify that one. Okay, so whether they are the genuine products or not. It in one of the member is intentionally doing some wrong things for the financial benefits, you can find out who is the. But during normal time, if you, as I said, in that horse meat scandal, after lot of investigation, the interviews and the trials, finally they found some one or two companies who did intentionally that benefits. But here we can very easily identify it, who has done that change in that the network provider. It could be your supplier, distributor, anyone. It provides a tamper proof digital certification body, give you the certificate for the that organic product or whatever it may be. They cannot change that digital record. So what are the mechanisms? Blockchain based digital identity checks for automated approvals. Risk reduction prevents fraud by ensuring only authorized parties can access the data. You can make sure that you are sharing that data with the only the authorized parties, and you are not sharing with the file to track transaction and verify the authenticity. Again, you can do the traceability tracking of the whole supply chain. It ensures the software file integrity and prevents the breaches as well. You cannot make any changes in the digital records. Transaction validation, tamper proof digital ledger for supply chain transparency. To improve the sustainability, increases the traceability to ensure ethical sourcing. Ethical sourcing is one of the important components. You need to make sure that you are doing the ethical business, ethical sourcing. That helps to improve your society. It verifies sustainability claims for regulatory compliance. If one of the supply chain is saying that our product these claims against the their products, and you can verify those sustainability claims for regular sites to improve the environmental impact. Mechanisms involved: IoT tracking for real-time supply chain. Flexibility means supports different supply chain models across industries. So we discuss couple and another case studies related to seafood. So this blockchain, it supports the different improve the efficiency. It enhances the consumer trust by providing the product origin details. Solution, mobile based tracking and smart tagging. Then tell me some of the challenges. Now we have seen the benefits. So initial cost is high. Okay, what else? Data storage could be problematic. What else? Yeah, that is also true, because you are using this with to manage the huge amount of data, so consumption of energy is also very high. Anyone else would like to add? So legal and regulatory complexity, navigating diverse laws and regulation across jurisdictions. So you are doing the global supply chain, global supply chain, and follow the rules and regulations of the different countries. Okay, you sometimes need to follow those one legal and regulatory frameworks. So this is one of the challenge. Collaboration issues. Collaboration. Suppose you are the main player in your supply chain and you are trying to implement this one. Other small players, how you are trying to collect some confidential information from us, so that collaborations will be problematic because of the real time information from those members. Physical virtual gap. Blockchain can't detect physical challenge. We are all talking about the digital records. If somebody tampers the digital record, then only you can detect. Somebody tampered the physical object, that tag is correct, but they changed the object. Suppose fish is the tag is showing that it is a authentic one, but what happened when you there is a contamination in the physical changes. Centralization risk, corporate blockchains like IBM's limit access, increasing vulnerability. They have tried to implement this blockchain, but again only few companies they have implemented. But if you look at the developing countries, very few and lack of frameworks, regulatory complexities. So that is a technological barriers. Energy consumption, somebody data that contributes to the CO2 emissions. Security and privacy, frequent breaches, cyber attacks and privacy risks. Adoption and integration, slow adoption, integration issues with legacy systems. Companies they are slowly other integrated technology, IoT, your artificial intelligence, sometimes your cloud computing and so on. So that's why slow adoption. Cost and efficiency, high set. And this is the last slide, information transparency. Sometimes we say the the information should be shared with the other one. So what are the business OPEC means for any of variety of reasons no information is shared between the parties, even operational data. OPEC means no information only shared, interface condition or partial. So part of information is shared. Transparent means information is shared on a selective and justified basis. Mm-hmm. Which one we are saying? Yes, correct. I set up traditional databases. Yeah. So there is I know the problem with that last one. Good observation. Thank you. Any question? I will be uploading the slides, all the game, so Excel files of this blockchain game. You can go to this blockchain and you can see what they have done. All the slides are there. You can see how they are. Any doubts? Any questions? I hope you have understood something about blockchain today. Okay, something how it basically works. Where is it? So if you see this kind of hashes here, now you try to how it is generated. Ethereum, again another blockchain platform. You can see here transaction hash, block is there, age, from, to, amount, and anything, any doubts, any questions. So I have given all the references as well for all the slides, so you can check that references here as well. Okay, so everything I have given, very interesting papers are there, because you need to manage that huge amount of data, computing power. Suppose you have got the complex automotive supply chain, 1,000 suppliers are there, 1,000 distributors are there. So each distributor we have got one node. Okay, so 1,000 distributors, 1,000 nodes are there. When some new block is added, all those thousands of suppliers nodes they need to approve it. 1,000 nodes means you have got thousands of computers. Okay, so that's why it becomes very complicated. Let me show you very interesting one video, then you would understand it basically. Infosys blockchain, very easy to understand. We already talked about this one, but little bit.
Hello, 199.
A typical agricultural supply chain involves complex interconnected processes between various stakeholders such as the producer, inspection and insurance companies, logistics and shipping agencies, banks, manufacturer and importer before it reaches a consumer sitting in another corner of the globe.
These are the members of your
However,
supply.
in this long process, there are quite a few challenges. Importers find it difficult to track provenance, to understand the place of origin and quality of the imported produce. As the produce moves between multiple stakeholders, the ownership or custodian information becomes difficult to trace. Centralized bodies, especially private agencies that certify crop produce, may not be trusted by international importers. Information flow between stakeholders is sequential, leading to potential delays in downstream decision making. Overall, stakeholders lack transparency in this process and lose track of relevant transactions. So, how do we tackle these challenges? Introducing Infosys Blockchain. Any activity can be documented and stored in the distributed ledger only with consensus among all participating stakeholders, thus making the network more trustworthy than any individual entity. Untrusted stakeholders can transact amongst each other through smart contracts without the need for a stakeholder with information access in near real time. Short from Uttar Pradesh, information access in near real time.
We
Meet
have given
Raj
some one
Kishore
example.
from Uttar Pradesh, who specializes in mango cultivation. Every year, Raj sells a bulk of his mango produce to Mohan, who owns the Royal Pulp Factory in Uttar Pradesh. Mohan, in turn, receives an order to export mango pulp to Charles Becker, who owns Becker Packaged Foods in Germany. He will add details about his crops,
So this is
request
the details of
inspections,
the records.
and get his produce in short at the right time. The contracts between Raj and Mohan, as
this is a
well as
smart
between
contract
Mohan
between
and
the
Charles, are stored on the
Mohan and
blockchain
then
network
Raj.
as smart contracts. Relevant stakeholders certify the produce with standard certificates. Once the mangoes are harvested, Raj
You can see here contract between Raj and Mohan, contract between Mohan and Charles. Insurance papers are there for this Raj. Inspection certificates to make sure that your products are good quality.
generates the invoice and requests a pickup. The logistics company picks these mangoes up from Raj's farm and delivers it to Mohan's warehouse. The delivery receipt is updated and made available to all stakeholders on the network. Once Mohan accepts the consignment, the smart contract between Mohan and Raj is executed, and Mohan's bank will be notified to initiate an open account transfer to Raj Kishore's bank. The transaction details will then be updated on the blockchain network. Meanwhile, Mohan is busy making mango pulp to be delivered to Charles Becker. The pulp is inspected and certified as well. Mohan then issues an invoice to Charles. Charles tracks the provenance of the product entirely from where the mangoes were cultivated to the inspection and insurance details before accepting the invoice. Mohan then raises a shipment request with the shipping company. Once the bill of lading is uploaded by the shipping company, the smart contract between Mohan and Charles gets executed, and Charles's bank initiates a payment to Mohan's bank. Transaction details are updated on the network. Thus, Charles sitting in Germany is able to remotely track the provenance of the mango pulp imported from India. Infosys Blockchain.
That's the example of how the blockchain works. The members, those who are sitting in the Western countries, they can, with the help of this smart contracts, insurance certificates, they are they can see the quality of that product. Then they will see the certification, and then they will approve it. So that's just one example. You can go to then IBM's TradeLens digital blockchain. You can see how it works and all those things. There are so many applications of this blockchain in different areas. So then you could basically analyze those things. You could use it for research purpose as well, those technologies, how we could make it more efficient, the investment cost is there, how we could reduce that investment costs and all those things. And if you get the time, read that first paper as well, the first paper published in 2008. It is very interesting. Okay, I hope you had enjoyed this today's session, and I will see you tomorrow for last session. I will share these Excel files as well. You can see the worksheet, grades, random. It is available on their website as well. Lookups, function, private key, then public key. Tomorrow, Venkat, I think it will be again 3 to 5. So I will ask that Chinmay to send the time.